Algebra 2, Logarithmic Function, Characteristics and Equations. First, we define the logarithmic function. Logarithmic function is the inverse function of exponential function. What it means is you swap x and y. So this is a logarithmic function. So we rewrite this way. It's like y equals a function of x, but this notation is very general notation. Any function, we use this notation. For this particular exponential function case, we use log. Now we have to indicate the base a, so we write log and the base a, then x. Okay, so this is the general format of function. This is specific to inverse function of exponential function. So what kind of function that is? Let's say a to the y1 equals x1, a to the y2 equals x2. So y1 is log a x1 and y2 is log a x2. Since x1 and x2 you multiply together is a to the y1 plus y2, right? Okay, so what happened is log a x1 times x2 equals log a x1 plus log a x2. Does it make sense? Well, when you multiply and take a log, this is y1 plus y2, right? From this equation, you look at it very carefully. y1 plus y2 is this. y1 is log 1, log a x1 here, right? So what can you say? This is a formula. When you have a multiplication of a and b, log a and b is going to be log a plus log a, b. So multiplication become addition in the logarithmic function. Okay. Formula 2, a to the y1 to the y2. According to exponential characteristic, it's same as a to the y1, y2. And that means x1, y2. So when you multiply y1, y2, this guy, it's a log x1 to the y2, which is this guy. So do you get this one? Right? This part, bring it here, right? Okay. And that is y2 turned out to be this. You get it? Look at this very careful here. Okay, so log a to the b is b times log a. This is second equation. Okay, now formula 3, Log a to the 1 is 0. Is that correct? Because a 0 equals 1, right? Right here. And log a to the a is 1. Okay. Log ab equals log cb over log ca, because c x1, c to the x1 is b, c to the x2 is b. So you take the ratio of this. Okay, think very careful here. Just look at and just hold it until you get it. Okay, you got it? So this is formula 3. That is log base a b is the same as different base b over log a. Okay? Now y equal log a, x equals 0. Find the x value. Okay, so what is this x value? That means this inverse function, if you look at the original, this, right? And this is 1, so x equals 1. Okay. So you have to practice some, go through the practice to get used to this logarithmic function. Now, natural log, there is a special case when base is e. What is e? E is Eulers constant, which is this. And how you get the e? Well, use an infinite series. You can calculate e as many digits as it's one, but it's a irrational number, so it's never repeat. It's randomly number come out forever, 2.71828, randomly keep going forever. This is one of mystery of irrational number. Same thing happens square root 2, 1.4, and the number come out randomly. It's never repeat. It's not cyclic decimal number. If cyclic decimal number, it's not irrational number, because cyclic decimal number can be converted to the ratio of integer, which is a definition of rational number. Do you remember this discussion? Okay, so what's happened is this is irrational number, and very special. It's come out so many times. Euler, he's a genius of the math. He used this constant all over in the math theory. So we give a special status. Log e, we write log e, ln. That means this is base e. Okay? And sometimes we write this way. Log 10, engineering, we use log 10 often for the level of the sounds or noise. The 10, we often eliminate 10. We write this way. If there's no base, that means 10. And if ln, that means base e. And we have a capital log, and this one is a complex number logarithmic function. Okay, so those are math convention, just good to know. Simplify the following logarithmic function and draw the graph. Okay, first, you know this log can be separated to right, and This one is simply shift function by amount of -1. The shift function by amount of 1. Since log function is shifted like this and shifted like this, it's going to be 2. So you add them together, it's going to be somewhere around this. This is going to be the function. Okay. So one thing you have to know about log function is exponent function goes up. So exponent function y equals ex is always positive. The inverse function, definitely x and y swapped, so x is always positive unless you shift it. Okay, so if you don't shift it, x is positive. What happened to negative x? It's not defined. So if you have log a and a is negative, this value is not defined. Okay, you don't feel comfortable about this? Well, I tell you, there's something else not defined, like 3/0. What is this value? It's not defined. It's not number. It's not rational number. It's not irrational number. It's not any of number you know. Well, you can claim this. You can put a name and claim this is a number, some kind of number, but what can you do about it? Nothing much. Okay, unless you develop the new math theory based on this. Okay, simplify the following logarithmic function and draw the graph. Simplify. So this is going to be a, so same as log x minus 1. So simply you draw this one, which is a shifted function, and multiply by a. So it's looks like this. Okay. So can you find out the intercept here? When x is 0, it's a log 1, and log 1 is y is 0. A log x minus 1 is 0. And you know when log a is 0, right? A is 1. So x is 2. So this is 2. You get it? Okay. Keep going. Decibel uses logarithmic function with base 10. Okay, here you go. Decibel means 10 times log 10 p1 over p2. That means this usually p1, p2 is power level. So suppose you have a signal to noise and signal, the ratio, you take log 10 and multiply by 10. That's going to be the noise signal ratio defined by decibel. Okay. When the ratio of power level is 12 using base 2 logarithm, find the decimal level. Okay, so how do you change to base 2? Say decibel is 12. So log 10 P1 P2 equals 1.2, right? So this one is log P1 P2 over log 10. So using E, this ratio, the decibel using E is going to be 1.2 log 10. Okay, you can calculate this log 10, and if you want to put the E, then you can multiply E here on the both sides. That's going to be new definition of decimal. Okay, so simplify the following logarithmic equation. This is the practice. You stop the video and you do yourself. The first one, the multiplication is separated and the power is going to come front, right? That's easy. And this A, log A is 1, so you separate this and the remaining become 1. Why don't you practice this on the paper and pencil? You can stop the video, go through this. Here's another exercise. Solve following mixed problem. It's getting a little bit more challenging. Okay, a little bit beyond SAT 1, but SAT 2 level. So if you are planning to take SAT 2, you should practice this. Okay, the SAT 1, they don't talk about exponential function or logarithmic function, but SAT 2 they do. So if you're planning to go to a major university and engineering degree or science degree, you have to take a SAT 2 and you have to practice this. So go ahead, take time and practice this. It has an answer is in the red. Okay, so let's think about what the problem. 200 mice in a mouse farm, right? This type of mouse reproduce once a year, and each reproduction are 6 new mice for a pair, assuming that the ratio of male and females even 50%, and the farm sells 550 mouse each year. How many mice will there be after 3 years? We start selling mice next year after the initial production. Create a formula to calculate n years. Okay, so after the first year, it's going to be 200 the parents, right? And each one 100 male and female that produce 6 each, and we sell 550, so 250 left. So next year 250 is the parents, then use the same formula, we have 550 left. The third year 550 become 1650. Nth later, you deduce this formula by n, right? Okay, so if you do this, this is the formula, and I guarantee you get a lot of mice at the end. So, but later you have to factor in some mice will die for various reasons, so we had to deduct some more. 550 sold and minus some mice, and the amount of mice die for various reasons depend on the total number of mice. So you have to factor that in, not the constant 550 minus the some ratio times total mice. So that's what the formula is going to be. A little bit more complicated than this, but it can be done, right? Okay, great. Human ear sensitivity scaling is known to correspond to decibel scale. The perception of the sound loudness is the logarithm of sound's power. We increase the power by 4 times. How much will sound's level increase by this power increase? Okay, so your perception, when you increase the power 4 times, how much you feel it's increased with the human ear. Okay, so what you do is you take the decibel and 4 times, right? So P2 is 4 times P1. Okay, the increased level, increased power, the perception of sounds increase is only log 10 4. Therefore, perception of sounds by human ear is increased by 6 decibel only. What's 6 decibel? Well, the point here is, even you double the sound, you don't feel it's doubled, because perception is rather linear. Although the sounds increase is multiplied. Okay, so that's a logarithmic function. Even you increase something by doubling, the result is just linearly increasing linearly. Okay, so that's a logarithmic function. On the other hand, the exponential function, you increase linearly a little bit, then result is going to be double. Okay, so there are a lot of this type of event or phenomena in the nature, and to describe those, linear function is not enough. So you have to come up with kind of describing equation using exponential function or logarithmic function. Logarithmic functions, the independent variable can change great amount, but the resulted dependent function change modulately. Okay, and exponential function is the opposite. Okay, so that's all about logarithmic function. I hope you enjoyed listening this video, and I'll see you in the next video, Algebra 2.